Now that I've got the lathe working, I'm starting to think I would really like some variable speed motor on here. So I have found a treadmill, and I pulled all of the guts out of the treadmill. So this is a pretty common upgrade for a lathe or a lot of different shop tools. So if you just, search for treadmill motor, a treadmill motor lathe or drill press or bandsaw or whatever, you can find all kinds of stuff. So I've pretty much just gutted this. It was a Sunny T4400 treadmill, and the key part here is this motor. So let's take a look at the motor. So it's a DC motor, 90 volts, 5400 RPM, 2.2 horsepower. This is a pretty standard treadmill motor. And the motor did have this really heavy flywheel with a pulley on it. I don't think I will be needing that for any reason. It's driven by this circuit board here, which I was really hoping took like a PWM signal or something that I could, make a controller for. But apparently it takes some kind of serial communication with some protocol I don't recognize. So I might just have to, at least for now, make use of the actual control panel from the treadmill. Other pieces that came with it, this pretty nice looking EMI filter, switches, circuit breaker, all the wiring. So I had this old stereo that stopped working a long time ago, but I've been holding on to it for some reason, and today I found that reason. Don't need that. I have put all of the parts of this motor, most of the parts of this motor control circuitry inside this box, which was part of the stereo, and it just happened to have some holes that fit my needs nicely for the switch, circuit breaker, cord, and everything just fit in here so nicely. So I can just close it up. I'll stick the screws in a little bit later. All right, it's plugged in, and I'm gonna try switching this on. Turn that on. We can see the controller has turned on. Then I'll hit start. It has a little countdown. Yeah, I don't know if you can see that, but yeah, the motor is turning. And now let's try speeding it up. And you can probably hear that. So about now, it got up to speed. It takes that long to speed up. And let's actually take it all the way up. It goes up to maximum of 9 on this thing. And then see how long it takes to stop this. So I hit stop. All right, and that's way too long. If I'm working on the lathe and I want to stop it to, check something or adjust something, I don't want to wait for that long. All right, I need a pulley for this motor. It is about 0.67 inches. That is a 17 millimeter shaft. I'm going to make this pulley out of this really nice piece of plywood. So I'm going to make it about 2.5 inches When I have a choice between buying a solution and hacking one together, I tend to go with the latter. So here's the actual circuit board from the controller, and I guess first of all, if you are, trying to upgrade your wood lathe, you're a woodworker, you may not be an electrical engineer or an embedded systems designer, so you might not actually want to dive into this. This is the thing that takes the mains voltage and then outputs to the motor itself, and it takes a control signal coming from that control panel that we saw. And this little board contains all the main parts needed. It had a big old heat sink that it was on. I've taken it off so that I could take a look at traces and things. Now, I'm no electrical engineer, but I like to dabble with this. This little board has everything I need. Well, almost everything I need to control that motor. I've come to the conclusion that I could, somewhere around here, I think it's right here, there's a little trace that I can cut. And then there's another one up somewhere around here, just a tiny trace that I can cut. And then solder in a jumper from about here to up here somewhere. And that just essentially bypasses all of this junk. Now, what is this junk? This thing right here, this is a microcontroller, which is taking a signal from that control panel, the interface for the treadmill. This particular one had some serial communication, and it would talk to this chip, and then this chip would generate the PWM signal. And I just want to basically remove this whole chunk, replace it with my own logic that is not, treadmill appropriate logic. Basically what that gives me is now the wire coming in here would go through this optocoupler for isolation, and then it would just directly run this little bit of circuitry. There's a trio of diodes here that they drive this big MOSFET back here. And this is what's switching the current to the motor. And so basically I can just go directly from my pulse width modulated signal to drive this MOSFET. There is one more issue. I noticed a relay right here. So this controller actually switches on and off the power, so the main power coming in. And so I'll need to either, bypass that relay, or I might want to drive it. Maybe not. No, it's probably not too useful for my application, so I'll probably just bypass that. Most of this junk down here is to create an 8-volt power supply for all of the logic. So I will be using that, to drive the MOSFET. It's making use of that power. All right, so here I have removed that relay and just put a jumper in here, cut the 2 traces, and then soldered in this jumper wire here. And I'm going to do something that I would never recommend doing, actually plugging this thing in. This is going to have mains voltage on it, and on the other side, instead of hooking up a motor, I've hooked up just this little light bulb. And then over here, I'm just going to touch the pin, which should turn on this optocoupler. That should turn on the MOSFET, and we should see the light bulb light up if everything is working the way I'm hoping it does. I'm going to stay far away from anything. The only thing I'm going to touch is that pin, which is completely isolated. But still, I'm not going anywhere near this. Okay, so it is live now. It's on. And if I touch that pin there, yep. Did you see that? So this is what I was hoping. So if I just put a, high voltage, in this case 8 volts, on that pin that's driving that optocoupler, indeed the power MOSFET is turning on. Excellent.